Hello everyone. With this video, we are going to start a series about pointers, and this one is Introduction to Pointers. So pointers are going to be very valuable in upcoming applications. So let's get started with the very basics of what a pointer is. Introduction to Pointers. So that's what this first lesson will be all about. So we'll start at the very beginning. And let's start with the definition of what a pointer is. A pointer is a special variable that contains a memory address. So it's a special kind of variable. It is still a variable, but it can only contain the address of something. It can contain the address of, say, the letter X. It can be the address of the number 17, and so on. So a pointer is just a variable. It's a very special variable which can only contain a memory address. Now, it will help if we can take a look at some basic computer architecture to get an idea of what an address is. So let's take a look at that first. So here's a block diagram that you'll see in a lot of introductory programming books. So it's a very simplified diagram, but it will serve to get the point across here. Our goal here is to learn how to use pointers, so we just have to have some mental image of what this thing is all about. So in a simplified block diagram, then a computer is shown here in this diagram, where in the middle we have the kind of the brains of the computer, the central processing unit, and inside the central processing unit there is electronic circuitry that does the arithmetic. So it can do the additions, both in integer additions and floating point additions and things like that. Plus, there's also what we call a logic unit. And whenever you write an if statement that results in true or false, then you're going to be invoking this logic unit in some way. The control unit is responsible for communicating between the brain, here the central processing unit, and this high-speed memory. All of the information that is processed by the central processing unit has to be stored in your high-speed memory that is located on the same chip, or very tightly coupled to a chip that does the central processing. So when you buy a computer and you notice it has like 8 gigabytes of RAM or 12 gigabytes of RAM or whatever, then this is the memory that they're talking about. This is a super high-speed memory where everything is stored whenever your program is being executed. Now, you know, we have a lot of other devices that go with the computer, and in general we just have input devices, which are things like the keyboard, could be the mouse, could be a microphone, could be a lot of things. And so this is like a communication link between the human world and the computer itself. And we have a number of output devices as well. So, you know, the monitor is a typical output device, printer, speaker, a number of other things could be over here as well. We also have these auxiliary storage devices. So these are much larger. So this would be something like your C drive if you have a Windows computer, and if you have other kinds of computers, then you're going to maybe name these things differently. But it's going to be where the large amount of storage is, and typically this would be in the terabyte storage range and that size. But it's much larger than the high-speed memory over here. But the connection between the CPU and the high-speed memory and this auxiliary storage device is tightly coupled, and information is moving between these all the time. And that's under the control of our control unit over here and various other things. Now, what I want to do is to expand the high-speed memory, because that's what we need in order to get a mental image of what these pointers are all about. So if a pointer is a variable that can contain a memory address, then just what does that mean? Well, let's look at a block diagram of that high-speed memory. Some basic definitions. In this case, I'm showing a 32-bit word where we have bytes 0, 1, 2, and 3. And you notice those are kind of laid out like the powers of 2 we had earlier. So byte 0 is usually shown over here on the right, and then bytes 1, 2, and 3 to the left. And each byte, of course, is 8 bits. So if we have a 4-byte word, then that's 32 bits, and that's pretty common. Other types of words these days, you can also have a 64-bit word, so that would contain 8 bytes instead of just 4. But we'll just deal with 32. All right, now the address is shown over here in the column on the left. If you have a large RAM, random access memory, then this is going to be a large memory space over here. But regardless of what it is, we start at address 0, and we will go down to whatever that last address is down here. And if you have a 8 gigabyte memory, 8 gigabyte RAM, then this last address is 8 billion down here. So we have a large address space, and then we have the information that's contained in each of those addresses. So the left-hand column, that's going to be an address. And then the columns to the right of that, all 4 of those bytes, those are going to represent 32 bits that actually contain some information. So if we look down here, for example, at this address, then at address 650,000, we could have the number 8 stored in here. So things like that. So you have the address and you have the contents of that address, which is the information that we want. In our program, we use variables, and those variables are translated into these addresses. It would be very hard to write programs if we had to remember that address 4500 contained the value 7, or the address 6000 contained the letter A, things like that. So it's we don't use that in programming, we use variables. The various systems like the compiler, the linker, the loader, and those things, they will convert that variable into an actual address so that when you get to loading and running your program, then that variable is going to be represented by some address in main memory. Now what? Okay, regardless of what kind of computer you have, the information that's contained in the main memory consists of several things, and most importantly, we have your operating system. So that's the first thing. So the operating system, it could be Windows, it could be your iOS on a Mac, it could be Linux or something like that. Whatever it may be, and no matter what you're trying to compute, what kind of program you're running, it has to be in main memory. So some portion of this main memory is going to be dedicated to the operating system. Now, not all of the operating system may be in there at once, but certainly a substantial amount of the system has to be in there in order for the computer to actually run. So it's the program that governs the computer. That's the operating system. Then, on top of that, in some additional storage space, there are various applications. So if you happen to be running Visual Studio, as I'm doing in this course, then you have to load in or start up. When you start up Visual Studio, it gets loaded into memory as well. And again, not all of it will be loaded at once. It's kind of too big to all go in at once, but the portion that you're using will be loaded into main memory. It has to in order to execute. So you have your operating system and you have applications. It could be Visual Studio, it could be PowerPoint or Word, it could be a game that you're playing, whatever your application might be. Whenever you start it up, then a portion of that has to be loaded into the main memory in order to run. In this course, we have programs that we're writing. We're writing C++ programs. Those occupy memory spaces as well. Now, those are usually going to be way down here somewhere. The operating system is going to occupy the lower order addresses, and then the other applications get put in. So our program is going to be down here. Now, I'm showing this in this block diagram. They're kind of all together, but in reality, they'll be scattered about. So if you notice, here is address 550,000. So part of our program could be in here, and here's address 650,000. So a different part of our program could be in here. So I'm just showing it as consecutive memory locations, but in reality, it could be scattered across these big blocks of memory down here, and that is under the control of the operating system. Now, the last thing that we have in here, let me undo something there. I think I added a cell or something. Then we have the data. So your program is going to accept data and it's going to generate data. So we need to have locations in memory for that data as well. Back up here when we're looking at the block diagram of the computer itself, then within the high-speed memory, this control unit is going to fetch some instructions from memory, and then those instructions may need data. So if we're doing an addition operation, then the addition operation is loaded into the central processing unit, but in order to add things, it needs to have the two things to add. So under the control of our central processing unit, the information is transferred between the high-speed memory and the arithmetic unit or others. So within our main memory, we also have to have the data stored in here. So the data that you type in as input to your program will show up here, and the results that are produced by the program will also be stored here. And then eventually when your program completes, all of that gets written back out to either your auxiliary storage device, or it could be a printer, or it could be the monitor. So what you need to keep in mind is that there is this main memory that's part of your computer, and each one of these words has an address. And in fact, each byte typically has an address. So we have what's called byte addressable memory. So we have addresses and we have the contents of those addresses. All right, so hopefully now that gives you a mental picture of what we're dealing with and what we're talking about when we talk about memory addresses. Now let's look at a C program which does involve pointers. So this is a very, very simple program. It's really nothing more than just our template for a C program. And we just have a couple of variables declared here: ordinary integer values 7, number 7, values 5. So you've seen that already. But how do we declare a pointer? Well, to declare a pointer, we use a special notation. And that notation is shown here. So we'll paste that in. And here is the way that you declare a pointer. We use a special symbol. So here is the asterisk that shows up. Now, in some development environments like Visual Studio, it likes to put the asterisk right next to the type. And I prefer it to be next to the variable. So this is the declaration for a pointer. And let me also adjust that. So you can declare a pointer to any type. Here I'm declaring this pointer to be a pointer to an integer. And you can use float, you can use double, you can use string, you can use any legitimate C++ type here. The syntax for this is you precede the name of the variable. So you can choose whatever variable you want the same way you would with the ordinary variables. I'm preceding my pointers with this PTR underscore to emphasize that this is a pointer. And if you want to initialize a pointer, you have a built-in reserved word that you can use for that, and it's called null pointer, Nullptr. So this is the syntax that you would use when you are declaring pointers. I have an integer called pointer number that will point to an integer. I have another one called pointer value that will also point to an integer, and it's initialized to the null pointer as well. Now you may notice that my ordinary variables, I've called those number and I've called those value. Well, I want these two pointers to point to the integer number and to the integer value. Keep in mind that this pointer is a special type. The pointer itself is not an integer. It is a pointer to an integer. A pointer is a variable that contains a memory address. So you cannot just put an integer directly into this. You have to put the address of an integer. Same way with this one over here. This one, pointer value, it is not an integer. It is a pointer to an integer. Now, how are we going to use these pointers? Well, if a pointer is a variable that contains a memory address, then we have to put into that pointer some address. And I'm going to put in the address of the number, the variable number, into pointer number, and I'll put the address of value into pointer value. The way that we do that is by using our address operator. So let's go ahead and put the line of code in here that will do that. So I'll paste those in. And here is how we set the value for a pointer. You may recall that we used this ampersand when we were passing a variable to a function and a call by reference. Well, here it shows up again. So the ampersand preceding a variable is called the address operator. So it will not put the value 7, which is the number up here for the value for number, which is 7. It will not put 7 into pointer number. It will put the address of that variable number. All right, so number has an address in memory. It has a contents in memory. So we are going to take that address and we're going to store it into pointer number. Therefore, pointer underscore number contains the memory address of the variable number. In the same way, we're going to get the address of the variable value. Okay, value is declared up there, and we're going to get its address. To get its address, we use the ampersand, and that gives us the address in memory of the location of the variable value, and we'll save that into the pointer value here. So we have these two new symbols. When you are declaring a pointer, we use the asterisk, and we're going to see the asterisk used again related to pointers coming up. But when you are declaring the pointer, you have to use that notation. So preceding a variable with the asterisk means that it's a pointer to something. So you see that notation here. The other operator is the address operator, and it will give us the address of where that variable is stored in memory, and we will save that into our pointer itself. So the pointer then contains the address of number and the address of value. Now let's print out some of these values so that we can actually see them and trace what's going on. So I'm going to put a couple of lines of code here, and I'm just going to print out some information. So here is just a normal cout statement that you've seen many times. We're just printing out what number is. So we have cout, we have number equals, and we'll print out the value for number, which is 7. So this will just print out number is equal to 7. The address of the number, well, if we can see that as well, we can print out the address of the number. So I'm going to use the address operator, and I'll print out address of number equals. Then using this ampersand as the address operator, I'll get the address of number, and I'll print those out. So just looking at those two lines, let's compile this program and run it, and then we can determine the actual location in memory where the variable number is stored. Let's look at the result. So here we have the output. And let me scroll up so we can see the cout statements. All right, so we have number is 7. So that's what you would expect. Now the address where number is stored is given by this hexadecimal value here. So that's some memory location represented by a hexadecimal number. That gives us the memory location. So you can see, that's certainly not an integer value. That's some special thing. That's a memory address. Each time you stop a program and then you run it again, the various tools that come with your computer, the linker, the loader, and all those things that you never see, they will load your program into a different location each time for execution. So if we run the program again immediately, we'll get a different address for this. So let's just take a look at that. So I'll stop this, and then I'll start it up again. Then we'll look at the output. Where is it? And this time you'll see that we get a different address here. So that will happen. Your program will never be loaded into the same memory locations on successive runs. So when you're running this example, you are going to get a different address here altogether than what I'm showing. So now we have that much. We have shown then that this ampersand will give us the address of the value of the variable. It will give us the address of the variable number, and then number itself contains the value 7. Now let's continue a little bit, and let's print out some other information pertaining to these pointers. But first, let's see the address of value. Let's do that next. So let's paste that in. So I'm going to print out value and then just a variable value, which we know is 5 up here. And I'll do the same thing. I'm going to get the address of value with the ampersand, and I'll print that out as well. So now we can see the addresses of number and of value. So let's just go along one step at a time here, and let's run this program and look at the output. Now we can see that we have the addresses of both number and value. So the address of number shows up here, and again, it's different than the previous run. And here's the location for the address of value. Now they're close together. You can see the 00EFFC6. That part is the same, and that part is the same. So this one is going to be the hexadecimal address C on the very end, and this one's going to be 0. So these are relatively close together in memory. So we now have the addresses of number and we have the addresses of value. Knowing that a pointer contains the address of a variable, we can use the pointers now to get the same information. Okay, so let's stop this and let's add the code so that we can see the output in terms of the pointers. Now these two lines will print out the values for pointer number and for pointer value. Notice that there is no ampersand here or here. We just print out the variable pointer number and we print out pointer value. What's a pointer? A pointer is a special variable that contains a memory address. These two lines up here assigned the address of number to pointer number, and it assigned the address of value to pointer value. Now let's just print those two things out. So these pointer variables will contain the addresses that we had here, the address of number, the address of value. So let's prove that by compiling and running the program. I'll bring in the output. And here's what we have. So number is 7, value is 5, and we got the addresses here. We have the address here. And we stored those addresses into the variables pointer number, pointer value. So when we print out pointer number and we print out pointer value, then of course we get the same thing. So pointer number, that's a variable that contains a memory address. It contains that address, which is the address of the variable number. So you get the idea? Pointer value, it contains an address. It contains the address of value. So here is what pointer number has. That's the contents of the variable pointer value. So that is the same as the address of the value that we see here. So when you have a pointer, then you have a variable that contains a memory address. And we'll gradually work up to how we can use these things. If we have the addresses of value and number stored in pointer number and pointer value, then how can we use those pointers to get the data that is stored in number and value? That is, how can we get to the number 7 and how can we get to the number 5 that we initialized up here? How can we get to that? Well, let's paste in 2 lines of code and I'll show you something new that we can do with that. Here is another use of the asterisk. So we see it here and we see it here. Let's look at the cout statement. The cout statement is going to print the asterisk pointer number equals, and then we'll use asterisk and pointer number here. The same thing for value. I'm going to print out the string constant star or asterisk pointer underscore value equals, and then we'll print out whatever that thing is here. Now, before I explain it further, I want to compile and run this program to show you what we get. Let's bring the output over. And here's the output. So when I print out star pointer number, then I get 7. When I print out star pointer value, I get 5. So what's going on here? What's going on is that we're using this asterisk in its second application to pointers. In this instance, when we're printing it out here and we're using it down here, what we're printing out is not the value that's within the pointer value, because that's an address. We're not printing out the address here. We're printing out what it points to. So here's a different use of the asterisk. And in this case, we use the asterisk to tell us what is the pointer pointing to. So this is called indirect addressing. We take the address that's stored in pointer number, and we know we've looked at that output. Here's the address that's stored in pointer number. Okay, we take that address, and then we go to that address. That address is the address of number. So this asterisk says we want to take the address of the pointer, then go to that address and print out the value that's stored there. So that's called indirect addressing. So we use a technique called indirect addressing, And the operator here is called the dereferencing operator. Dereferencing. So we have the address operator here. We have the dereferencing operator here. And I told you up above that we'll be using the asterisk differently. So when you use the asterisk up there, then that's not really a dereferencing operator. We're not accessing anything because we're declaring something. So when you are declaring a pointer, you use the asterisk here as part of the declaration. When you use it in this context, it's called a dereferencing operator, and that is saying to take the address that you have stored in pointer number, go to that address, and then get the value that's stored there. The little story I like to tell here about how this works, how this indirect addressing works, is as follows. Now, let's suppose, let's think of a kidnapping example, a pleasant one, not too horrible. And let's suppose that someone has taken your pet, which I know can be distressing. But at any rate, let's say that they have taken something of yours and they've left a note. So the note could say, please go to the coffee shop at 100 Main Street and receive further directions. So you want your pet back, so you go down to the coffee shop and you find there another note. The note tells you to go to another location and bring money, and then I'll give you your pet and you can get the money. So that's a two-step operation. You have to start with the address that's stored here. Then you go to that address, and that's what the star does. You go to that address, and then you use that address to go fetch the number that's stored there. All right, and that would be 7 in this case, and for value, it'll be 5. So that's what we see. We have a lot of new stuff here. So we have this indirect addressing, we have the syntax for pointers, and we have the dereferencing operations. Now, hopefully to clarify this even further, I want to make a map of some variables, just a simple one that corresponds to that diagram of a memory map that I showed earlier. So we're going to build a memory map. So I'll paste in a couple of lines of code just to set things up. And it's a pretty long line, so I'm just going to skip a couple of lines, and then I'm going to make a table. So I've just got a cout statement, and I'll have the width of 15, and I'm going to have the column headings. This will be the variable, and this will be the contents of the variable, and this will be the address of the variable over here. Okay, so you see we just have the end line on the end. All right, so I want to print out the, using the variables, just number and value, I want to print out some information. So let's add a couple of lines to do that. So let's paste those in. And what I'm doing here is I'm printing out what the variable is. Okay, so we have number and we have value. So I'm just going to print their name here under this column. Then I'm going to actually get what those variables contain. So we'll get the value here for number, and we'll get the actual value 5 here printed out. And then over here under the address, I'll print out what the address is for number and for value. So let's run the program and look at the table thus far. I've got some more to add shortly, but let's do this incrementally. Let's bring in the output. Okay, so here's the output, and here's the table. So I have the variable, and I've called my variable number and value. We know that it's 7. We know that value is 5. And then we have the addresses. So the address here of number is shown. The address here of value is shown. And that's the same thing we got up here. So you can verify that. You see that's the same thing, the address there, and the contents of the pointers as well. So those all match up. Now the next thing I want to do, I want to add a couple of lines here, and let's include our pointer variables, pointer value and pointer number. So let's put in the lines of code here. And this time I'm going to print out my information for the pointer variables themselves. So I'll print out the variable that's pointer number, and I'll print out what it contains. So we'll print that out here. So under the contents column, we'll see what pointer number contains. And over here, we'll see what it contains. And then I'm also going to print out the address. Okay, this is the address. Well, pointers have to have a place to live too. Pointers are variables. Pointers require storage and memory, so they have their own addresses. So I will also print out the address of the variable pointer number and the address of the variable pointer value. Then that'll be the end of this program. So let's run the program now, and let's look through this table. Here's the output. We'll bring that over. And now we can look at the table. So we had number and we had value. So that's pretty straightforward. Pointer number, that's a variable, and we know that a pointer is a variable that contains a memory address. So it must contain a memory address. Here's the address it contains. So in this run, then pointer number contains the address 00FEFB40. That's a hexadecimal value. Then the address where the pointer is stored is at address 00FEFB28. So the pointer is stored in memory. It has an address where it is stored, but it contains an address itself. This address, 00FEFB40, that's the address of number up there. So the pointer has a memory location where it's stored. The pointer contains a memory address, and that address points to a variable. And in this case, it points to the variable number, which contains 7. So that's the two-step process. Okay, the pointer, it has a place that it lives. So if the pointer for value, its address here in memory is shown 00FEFB1C. It contains the address 00FEFB34. That address is the address of value. So this pointer value, contains the address of value, and it's said to point to value. Pointer number, it contains the address of number. It's said to point to number. So now you can kind of see what is stored in the memory addresses, and you can kind of see how this works. The pointers, they're variables. They have memory locations. They contain addresses. Regular variables that we use all the time, they have locations in memory, and they have contents, and they have their own address. Do not be confused by the location in memory where the pointer variable is stored and the address that the pointer contains. Now, this video really shows the basics of how to set up pointers. The other thing that we didn't print out down here in our table is what they pointed to. So up here we printed out using the star notation what the pointer points to, and down here we printed out the address where the pointer is stored in memory. So these are the basics. Here's how you declare pointers, here's how you initialize them with addresses, and then we just print out information using those things. Before I leave this, I want to show you one other thing about declaring pointers. In most textbooks, it will tell you that you can use this notation. You can use integer star pointer, as well as putting it over next to the variable as I've done here. Now, my preference is to not put the asterisk there. I just don't like to do it, and let me show you why. Let's suppose I don't have the pointer over here on this second variable, pointer value. Well, because I'm trying to initialize it to the null pointer, I get an error, and the error is this. This first one, that is a pointer to an integer. But over here, I don't have the asterisk, so that is an integer value itself. It is not a pointer to an integer. So you need to be careful about that. So for every variable that you want to be a pointer, then you need to have the asterisk just to the left of it. Now, in C, it's okay to have blank space in here, so we could put a blank between those. You can have the asterisk there. You can have it up against the variable here like I prefer, or you can have spaces between them, and syntactically they all work out. But the important thing is you must have the asterisk preceding any variable that you want to be a pointer. Well, that pretty much covers the introduction to what pointers are. So we will stop the video here, and in upcoming videos we'll look at more adventures with using pointers. So this will be the conclusion of the video.